Hey folks, how's it going? It's Mr. Murray coming to you with a video on graphing two variable inequalities, okay? So hopefully by now in class we've seen the 4 steps to solving two variable inequalities. In the 2020 to 2021 school year, that was handout 2-3. I'll try to put a link in the description if you want a copy of that worksheet. What we're going to do is we're essentially graphing inequalities where there's an x and a y. Now, when you have one variable, what we learned is that you're just going to make a graph on a number line, and that's a whole different skill. But what we learned is essentially that you have a boundary line when you have a two variable inequality, and the boundary line represents everywhere where both sides are equal. So in this case, it represents the x's and y's such that y in this case is equal to x plus 4. So that's where they're equal. And then what we learned is that on one side is all the stuff where y is greater than x plus 4 in this case. And on the other side is where y is less than x plus 4. Okay, so the equal is on the line, the greater is on one side, the less than is on the other. And so what we learned is that we need to do 4 things. Now the first is we need to start by graphing the boundary line, all right? Because otherwise we're taking shots in the dark. So we need that nice fence that delineates the stuff that's greater and the stuff that's less, okay? We then need to determine if the line is supposed to be solid or if it's supposed to be dotted. And that is based on whether it's allowed to be equal to or not. In this case, y has to be greater than. There's no or equal to, so we need a dotted line. Because remember, the or equal to is what is on the line. So we need to know, is that okay? And if it is, we keep a solid, and if it's not, we make the line dotted. Then, once we have the line, we need to know where the true stuff and the false stuff is. And so what we do is we choose a test point. And remember, what I say is don't be a hero. Choose the point whenever you can, 0, 0. And that happens to be because 0 is usually, 0, 0 that is usually a relatively easy number to plug in. In this case, we would get 0 is greater than 4, and we know that that is not true. And that allows us to say, well, because 0, 0 is false for this inequality, the false stuff is on the same side as 0, 0, and therefore the true stuff is on the other side of that boundary line. That allows us to do step 4, which is to put in the shading, or as I say, throw that shade. So in this video, what I'm going to be doing is I'm going to be walking through a number of examples that I'm going to try, that we'll try together, and that I'll ask you to try. And my hope is through this video, you're going to see a bunch of different examples, and you're going to see that more or less the process plays out the same in all of them. This video will primarily focus on boundary lines that are either going to be in slope-intercept form or standard form, though as we discussed in class, point slope is another possible setup for an inequality, okay? All right, so the first one is one that I'm going to do, and as you can see, I've highlighted these 4 steps. So what I'm going to show you as I go some best practices that are going to help you out. So the first best practice is you always want to write the equation of the boundary line. And what we talked about in class is that the boundary line is like when you take the inequality and you replace it with an equation. That's all you're doing here. So instead of writing greater than, I'm writing equals. And this is going to let me graph a really, really nice boundary line. So actually, I placed it at +5. It should be at -5. And then what I'm going to do is I know that I'm going up 2 over 1, up 2 over 1, up 2 over 1, and so on. So best practice number 1 is to go ahead and to make sure you write that equation. Best practice number 2 is really to ensure that the boundary line crosses the entire coordinate plane. And that's because you're going to need to do some shading, and you really want to make sure you can graph as much as possible. Best practice 3 kind of goes without saying, and that's that you want to put arrows on the line, Okay, that's going to be important. Now we're going to go ahead. We've done step 1. We've graphed our boundary line. Okay, the next thing we're going to do is we're going to determine, is it solid or dotted? And again, what that comes down to is asking ourselves, well, is it okay for y to be equal to 2x minus 5? And in this case, it is not. And again, the reason is because we look at the inequality and we see it's not an or equal to, which means, for example, let's say I plugged in 0, negative 5. Let's just say I was to plug in 0, negative 5. What I would get is that negative 5 is greater than negative 5, right? That's if I'm just giving an example, okay? There's a number of examples that work out like this. And what we know is that this is actually not true. It's not true that negative 5 is greater than itself. Okay, so that's an example of how in this case being on the line is not allowed. So I'm going to go ahead and I'm going to make this a dotted line. Okay, so that is essentially step 2 complete. The third step is to choose a test point. So we can observe that 0, 0 is not on the line. So another best practice is to always plot your test point. And the reason is because depending on whether the test point is true or false is going to dictate whether I'm going to shade on the same side of the boundary line as that test point or the opposite. And so to help get your bearings, it helps to actually be able to visualize where that test point is. So in this case, we see that we've chosen 0, 0, and we're now going to evaluate whether that makes the inequality true or false. So I substitute 0 for y, and I substitute 0 for x, and I get 0 is greater than negative 5. Is that true? Yes, that is true. So based on that, I've now got my test point, and I'm going to throw that shade. So because 0, 0 makes the inequality true, everything on the same side of this line as 0, 0 also makes the inequality true. We can see, for example, that if we actually plug in a point on the other side of the line, such as 6, 0, we'd get something like 0 equals 2 times 6 minus 5. So that is 0 equals 12 minus 5, rather greater than 12 minus 5. So 0 is greater than 7. That's what I meant to say. So 0 greater than 2 times 6 minus 5. So 0 greater than 12 minus 5, 0 greater than 7. That is not true. 0 is actually less than 7. So we can actually see if we pick a number on the other side of the line, we are going to get something that is false. Okay? Now, a big misconception people make is they shade where things false. You always want to shade where the true stuff is. Okay? So don't forget about that. Now, I know this is kind of like an in-depth explanation, but I really want to make sure I hit all those key points. As we go down, I'm going to slowly pick up the pace. But if there's anything that's confusing you at this point, I strongly recommend you go back and take a look, rewind the video as needed, and then in a moment, I'm going to move on to another example. Okay, here's another example of an I do. So let's think about some of those best practices. I'm going to go a little faster now. So the first best practice, remember, is we want to be writing the equation separately. And that's because not all equations are going to be in slope-intercept form. And many people like to graph in slope-intercept form. And so one thing I said in class is if you need to convert to slope-intercept, in this case we don't, but if you needed to, that's okay. But please manipulate the equation. Don't manipulate the inequality. And I say that because manipulating the inequality for some people will actually lead to an incorrect inequality, particularly if it involves multiplying or dividing by a negative, in which case people forget to flip the sign and the rest of it goes south. You don't have to worry about that with an equation, and so that's why I say focus on the equation. Go back to the inequality when you're ready to get to step 2 and on. So what I know is I know in this case that I have an intercept of negative 5, and I need to be going up 3, 1, 2, 3, and over 5. And I end up here. Okay, now I'm going to go ahead and graph, boom, boom. and I'm going to connect through. I will go ahead and change the color on that. I am terribly sorry. I'd like that to be a black line. All right, now I need to know, is it solid or dotted, right? I've got my boundary line graphed. Is it solid or dotted? Well, here it's solid because being equal to is okay, right? So for example, if I picked 5, -2, what I would end up with is both sides equal, and that's okay, right? It's okay for both sides to be equal because y needs to be less than or equal to 3/5 x minus 5. So that's okay. Now I'm going to pick my test point. As you're going to see, 0, 0 is often not on the line, so that's a recommended pick. Let's go ahead and plug that in and see what we get. So I plug in 0 for y. And remember, for the test point, you go back to the original inequality. And see, this 3/5 would be annoying to deal with, and so we don't really have to worry about that because we're multiplying it by 0 and it goes away. So 0 is less than or equal to -5. Is that true? It actually is not true. And so what that means is that because this is false, everything on the same side of the line as 0, 0 is also false, meaning that everything on the other side of the line is what's true. So in this case, you do want to go ahead and shade on the other side of the line. Okay, folks, so please make sure that made sense and you understood the 4 steps that I went through: graphing the boundary line, determining it was solid, choosing that test point 0, 0, and plotting it as part of those best practices to make sure we can get a sense of, wait, where is the same side, where is the other side, and then throwing that shade. When you're ready, go ahead and we'll move on to the next problem. Okay, so again, we're going to pick up the pace, but now we are going to go into one that is in standard form. Okay, this is in standard form. So this is why I recommend first best practice, writing that boundary line equation separately. What that's going to allow me to do is it's going to allow me to convert this because I might not want to graph this in standard form. So what I'm going to do is I'm going to convert it into slope-intercept form, and I'm going to do that by first adding y to both sides. And there's many ways you can do this. X equals 2 plus y, and then I'm going to subtract 2 because when you get to slope-intercept form, you want y alone. So y equals x minus 2. Okay, notice how I'm not messing with the inequality. I'm leaving it alone. I'm just messing with the boundary line equation. So this is the graph I need, and I go -2, and I'm going up 1 over 1. Now, alternatively, you could use the standard form to find the 2 intercepts. You can do that as well, but because the slope-intercept form version and the standard form version are equivalent mathematically, it doesn't really matter which you choose because you should get the same graph, right? Equivalent graphs will be the same. Notice how I go into a life hack and I immediately make it dotted off the jump. So if you had a pencil, right, you would always want to do this in pencil and then use your eraser to erase every little bit. Just for time's sake, I'm actually going to use the dotted line feature to do that for me. Okay, so we have the boundary line graphed. We have a solid dotted line rather. And now we're going to choose our point. Again, notice 0, 0. And I love standard form because you get 0 minus 0 is greater than 2. And this means that 0 is greater than 2, which is false. And this gets at a very common misconception that people have. And that's that you just look at what direction the inequality is pointing. And people sometimes say if it points towards the y, shade above. But notice here it's pointing towards the y, but the test point actually indicates that everything above is false, because since the test point makes the inequality false, the false stuff is above the line, meaning the true stuff is below the line. So those kind of tricks, look to where the inequality points, are not reliable tricks. A test point will work every single time. Okay, so again, we convert to slope-intercept from standard. We graph and make it dotted because it's not or equal. We choose 0, 0. We find that it makes it false, and we put in the shade. All right, I'm going to do a couple of ones that involve special types of lines. So this is a special case where x is greater than or equal to 4. So when you have x is equals, right, the boundary line is going to be x is equal to 4. Remember that x equals is a vertical line. Okay, and in this case, it does need to be a solid line because it's greater than or equal to. So I'll make sure that line is solid. So why is it vertical? Well, remember, if you look along this line, every single point along the line, for example, 4, 0, 4, 1, 4, 2, 4, 3, 4, negative 4, 4, negative 6, every single point has an x value that is equal to 4, as this equation, x equals to 4, says. So again, we pick our test point, 0, 0. And we ask ourselves, is 0 greater than or equal to 4? No, it's less than 4. And what you might have seen is that we've actually had it be wrong, as in not work out a lot of times, and being false is actually really helpful because what it tells me is since 0, 0 is false, everything on the same side of the boundary line as 0, 0 is also false, meaning that everything on the other side is where I want to shade because that is the true stuff. Okay? All right, I'm going to show you another special case, and this is one with so this was an x equals line. This one here is going to be a y equals line. So in this case, what I want to do is I'm now going to set this one up. This one is going to be a dotted line. We can see that because it is not or equal to. So I suggested in class, I said, look, if you know the line's going to be dotted, you could make it dotted right at the beginning, and you could do 1 and 2 together. But if you really want to, you can also do the erasing every little bit as well. I'll leave that to you. All right, I'm now going to choose my test point of 0, 0 and evaluate. 0 is greater than negative 4. Is that true? Yes, it is. So therefore, I'm going to shade on the same side of the line as 0, 0, because since 0, 0 makes the equation or the inequality true, that is, everything on the same side of that boundary line as 0, 0 is also true. All right, so I know it's been a few minutes. My clock is looking at about 17 minutes, and I hope you've had a chance to really digest this. If you feel like you're at a really good place and you've got a strong understanding of things, I encourage you to dive into some of your own independent problems. Of course, there will be bookmarks and chapters, so to speak, for this video, and you're encouraged to watch it in your own time. Please go back and rewind and kind of review anything if necessary, and then we're going to start to slowly move on to some problems for us to do together. All right, this is a we do. So you can see that I'm slowly kind of peeling things back, and I'm now kind of starting to paraphrase the directions here, okay? So folks, let's think about it. We're going to do this together. What's going to be the first thing I'm going to do? What's that first best practice? We're going to write the equation of the boundary line, okay? Because we're going to graph that. Okay, now let's graph it. So we have a y-intercept of 3, and you're encouraged to get some graph paper and follow along with me, and a slope of negative 2, which is down 2 over 1, down 2 over 1, down 2 over 1, and so on. Okay, also if I go up 2, I'll go left 1. All right, so now I'm going to get my line. Now we got to ask ourselves, is this going to be a solid or a dotted line? It will be a solid line. Okay, don't forget your arrows on the end. For me, it's automatic. I'm fortunate like that. For you, it might not be, so you got to, put your arrows on there. That's, unfortunately, some of the most common reason people lose points. All right, now I go back to my original inequality, and I'm going to choose a test point. In this case, what's going to be my go-to test point based on the line? It's going to be 0, 0. So remember, don't forget to mark your test point, 0, 0. Now let's go ahead and plug it into the inequality. So 0 is greater than or equal to negative 2 times 0 plus 3. So this is 0 plus 3. So 0 is greater than or equal to 3. Is that true? It is not. 0 is actually less than 3. So where do I shade? Do I shade below the line or above the line? I'm going to shade above the line because since 0, 0 made the inequality false, everything on the same side of the line as 0, 0 is false, meaning that everything on the other side of the line is true. So if you need to go back and review anything, of course, I encourage you to do so. But then in a moment, we are going to move on to another one for us to do together. All right, so you can see I peeled things back even more because we're slowly peeling away those layers and we're working together on this one. So again, the first thing I'm going to do is to write the equation of the boundary line. Okay? Now this is in standard form, so let's do this together. Let's go ahead and put it into slope-intercept. So I'm going to subtract 2x from each side. 5y equals negative 2x minus 20. You should try to get in the habit of putting your x's first because remember, we're looking for it to be like y equals mx plus b. So it really helps you in being able to kind of determine what that intercept and that slope is. Now I'm going to divide by 5, and the key thing here is to remember to divide everything by 5. So we get y equals negative 2/5 x, and then 20 divided by 5 is 4. Okay, so I'm going to put minus 4, and then I'm going to go down 2 over 5, up 2, left by 5. Now before I draw my line, what type of line do I need? I will need a solid line. Okay, we'll keep that black, perfect. So let's go ahead and draw the line. I'm gonna use the real line tool on this one, since I've got the ability to do so. So just make sure, again, black, solid, beautiful. Let's do it. And I'm just gonna go ahead and drag this around. Okay. Remember, your will not fail card, if you have one, is a really great ruler we found. All right. Again, we can see 0, 0 is not on there, so let's pick that. And what's going to happen when you plug in 0, 0? Back to the inequality. What's the left-hand side going to look like? Because we're in standard form and you're plugging in zeros. You're not going to have anything left. It's going to be 0, right? Because 2 times 0 is 0. 5 times 0 is 0. Those zeros added together are nothing. There's nothing or 0. So we ask ourselves, is 0 less than or equal to 20, or negative 20, that is? It is not. And so what that means is we're going to shade where? Above or below? You're going to shade below. And again, putting that test point on the graph is a really, really big help. A really, really good practice in general. All right, one last redo, and then I think, as you can see, I'm going to turn it over to you to try a couple, okay? So I've got now this inequality right here. So let's break it down. What's the first thing I'm going to write on my paper in order to execute this problem? I'm going to write 5x minus y equals 5. Now what am I going to do with this? I'm going to convert it to slope-intercept. So I'm going to add y and subtract 5. And if I flip this around, I get 5x minus 5. So that means I have an intercept of negative 5 and a slope of up by 5 and over by 1. Okay, let's go ahead and plot. Am I going to have a solid or a dotted line? It's going to be solid. So I'm going to kind of play around with this a little bit. Perfect. And now what am I going to do? I'm going to choose a test point of 0, 0, because again, 0, 0 is not on the line. So I get 0 is greater than or equal to, because 0 minus 0 is greater than or equal to 5. Is that true? No. And again, you can see a lot of the time we've been false, and that's all right. It's okay for it to not work. That just gives us information to help solve the problem. So this is a case where being false is actually something that's really, really okay. All right. Okay, here's what I'm going to do. I'm going to move on to the first of a series of you try problems. So I like if you could have some kind of, it'll help you to have some kind of graph paper available, because I think by having the graph paper available, you're going to be able to try out some of these problems. So please have a piece of graph paper available. And what I want you to do is I want you to pause the video. I want you to try to solve this and do this graph on your own. And then when you're ready, unpause the video and you can see what I got. Okay, so what we're going to do, we are going to convert it first into, we're going to write our boundary line. We're going to convert to slope-intercept, and that turns out to actually be y equals x. And y equals x has a slope of 1 and an intercept of 0. So this is a case where you cannot choose 0, 0 because 0, 0 is on the line. My recommendation in class was to choose, you can't choose 1, 1, that's on the line too. Just choose another point, preferably one with a 0 in it, and try to keep the numbers positive, because that, if you have to have a number that's not 0, because that positives are usually generally relatively easier to work with. So plugging it in, what I get is 1 is the x minus 0 is the y is greater than or equal to 0. So I get 1 is greater than or equal to 0. Is that true? It is. So that means I'm going to shade on the same side of the line as 1, 0, because it made the inequality true. All right, round 2. So again, I got another inequality here. Let's make the most of this. Please pause the video. Try to graph this inequality on your own. And then when you're ready, unpause, and you can see what I got. All right, let's take a look. So again, the first thing I'm doing is I'm converting it to a line. Oh, but not equal to 0. Equal to 3. Okay, now I'm going to convert to slope-intercept form. So in this case, I'm going to minus x. 3y equals negative x plus 3. Now I'm going to divide. Make sure you divide everything. Y equals negative. Now in this case, it's like negative 1. So negative 1/3 x plus 1. Okay. So that means I'm going to go down 3 over 1, down 1 over 3, down 1 over 3. Down 3 over 1 would be negative 3. So I'm going down 1, remember it's rise over run, down 1 over 3, down 1 over 3. Okay, and if I go up 1, left 3, up 1, left 3. Okay, as with before, I believe, as you see here, right, here we had a solid line. Here we are similarly going to have a solid line, just checking to make sure we got all our parameters there. Okay, we're going to choose 0, 0 because that is not on the line, so it's an option, and I get 0 is greater than or equal to 3, and that is false, so I'm going to shade on the opposite side of the line, above it, because 0, 0 makes it false, so everything on the same side of 0, 0 is also false. All right, last problem for you to do. This one's hopefully a little bit more familiar, but in any case, please take a moment to pause the video. Try this problem. Then when you're ready, unpause, and you can see the final you try solution. All right, let's get it. So we got y equals negative x minus 5, and we're good to just really jump in and start graphing. Okay, so we've got a slope of negative 1, so it goes down 1 over 1 as we go from left to right. Make sure you do make this line a dotted one because it's not okay to be equal to. Okay, because this is not an or equal. Okay, since 0, 0 is not on the line, we'll choose 0, 0, and I get 0 is more than negative 5, which is true. So I'm going to shade on the same side as 0, 0. Okay, so folks, I hope you found this video to be helpful. And so in this video, we really broke it down and we talked about graphing two variable inequalities in terms of those 4 crucial steps. So hopefully through this video, you've seen we must be able to determine the boundary line graph simply by taking the inequality and replacing it with an equation. We can manipulate it as much as we want. It might help to put it into slope-intercept form, but never touch the inequality. Only touch the equation. Do me and you a big favor, and it's going to really avoid a lot of mess ups. We're going to then determine if it's a solid or dotted line. We can determine that as we graph the boundary line, or if it's dotted by taking our eraser. Okay, remember, always good to graph with pencil. We're going to choose a test point and determine whether it makes the inequality true or false. And then that's going to lead us to doing some shading. All right, folks, so this is definitely not an easy thing, but really we got to keep working at it. I really believe in you. Keep it up. Stay positive. And remember, you can do it. All right, until next time, folks, have a wonderful evening, and don't forget to love math.